My subject is microwave communication and television systems, and in this today's topic is azimuth and elevation angle and apogee and perigee. So in the previous videos I have told about what is an satellite, what are the uses of satellites, and what are the advantages and disadvantages of satellite communication over terrestrial radio communications, and what is the classification of satellites. So it is basically based on different parameters. It is going to be classified based on the signal processing, based on the height. Okay, so based on our domestic usages, and based on the signal processing, based on the purpose, based on the area of working, like that we are having the classification of satellites. And not only with that, what is the microwave link, and what is the block diagram involved in the microwave link, what are the blocks which are going to be used in our circuits, and we have explained each term of that particular block diagram. Okay, and I have told about the applications of satellite also. Okay, so when we are having the satellite communication, or what is a satellite means, it is a revolving body which is revolving around the larger body. Okay, whenever we are having the satellites, we are calling as it is an microwave repeater link. It is calling as an microwave repeater link that will be revolving around the earth. So that means it will be receiving the signals from the transmitting earth station and amplifying these signals. It is going to be down converted and is sending these signals to the receiving earth stations. And satellite is nothing but a physical object that is going to be revolving across the larger body. Our solar system is a perfect example. Why? Because the earth and other planets are satellites which revolving around the sun. The moon is an natural satellite of the earth. Why? Because it is revolving around the earth. Okay, so this is the concept of satellites, and we are having number of satellites that is going to be introduced. In the previous class I have told about the history of the satellite, and I have told about the advantages and uses of microwave links. Okay, so why? Because it is a satellite, it is similar to that of a microwave link, and the microwave link is nothing but the same function as that of the copper wire or coaxial cable or fiber optic cable, but in a different manner. Why? Because it is using point to point microwave transmission between the repeaters. In the microwave link is also receiving the transmitted signal from the microwave transmitter, and it is amplifying the signals and it is retransmitted. So like this, both are having the same operations, but in some conditions we are going to be calling as microwave link, in some conditions we are going to be calling as satellites. So simple difference is there between the microwave link and satellites. Why? Because I have already told that a satellite is nothing but an microwave repeater link. Okay, so it is same operation. And when we are having the satellite communication, what is the need of satellite communication means, we are having number of reasons to use the satellite communication. Why? Because in our radio wave propagation, in that we are having number of layers along above the earth's curvature. Whenever the skywave propagation is going to be done, in that whenever we are passing the high frequencies, that is more than the 30 megahertz, it is having some problem. Why? Because when it is going to be reaching towards the ionosphere, that signals are not reflected back to our earth. Why? Because of the high frequency ranges, it is going to be penetrating through the ionosphere. So because of that, it is not going to be reflected back to the earth's station. Okay, for that we have to use some repeaters. So what it does means, it should be accept that signals and it should be amplified, and it should be downlinked towards the earth station. So for this purpose we have created a body that is not a stationary body, that will be above the earth. Due to gravitational force of the earth, it is not going to be a stationary body. Hence it could be only a revolving body around the earth, calling as satellites. And whenever we observe that satellite from the Earth station, it looks like a stationary body. Okay, why? Because the velocity of the satellite or velocity of the body and the velocity of this Earth is going to be same. So for that reasons we are going to be needing of a satellite communications. And in this we are having the classification of satellites only based on the signal processing. We are having the active satellites, we are having the passive satellites, and based on the height we are having the geosynchronous satellites and also non-synchronous satellites. Okay, and based on the purpose we are having communication satellites and observatory satellites, and based on the area of working we are having DOMSAT and at the same time Intelsat. DOMSAT is a button which is going to be used for domestic purpose. Intelsat is going to be using for international telecommunication purpose. Okay, these are the classification under the satellites. Okay, and when we are having the advantages, the satellite communication is having the high capacity transmission over longer distance, and it can be having the wide range, and the quality is also going to be very increasing with this using of the satellites. And the cost of the satellite, it will not depends upon the distance between the transmitter and receiver, and it is very cheap way of sending some informations, and economically it is doing the point to multi-point communication. It is also doing the multi-point to multi-point communication also. Okay, and what are the drawbacks means it cannot be repaired. Why? Because if it is placing a satellite, we are impossible to have a repair of that particular satellite when it is in the failure condition. And it is mainly having the time delay between the telephone conversations or data transmissions because of the varying the propagation path. So this is the advantages and disadvantages of satellites. And the applications of satellites are going to be TV broadcasting, GPS, that is global position system. It is going to be used for navigation, military, for internet purpose, and radio and TV program distributions, and having a weather reporting, that means forecast applications, weather forecast applications. Okay, like this we are having number of applications by using the satellites. Okay, and today's topic is elevation and azimuth angle, apogee and perigee, and uplink and downlink frequency, and some quiz points on these topics. Okay, so whenever we are having the satellite communication, to optimize, to decrease the performance of the to have a synchronization of the performance of the satellite communication system, the direction of the maximum gain of an earth station must be pointed directly at the satellite. To ensure this, the satellite, that is earth station antennas, is going to be aligned into two angles. That means it is determined in two ways. That means in order to optimize the performance of satellite communication systems, the direction of maximum gain of earth station must be pointed directly at the satellite. To ensure this, we are going to be having aligned into two angles is going to be determined. So they are azimuth angle and elevation angle. So what is an elevation and what is an azimuth angles? So whenever we are calling as an azimuth and elevation angle, they are referred to the antenna look angles. That means basically based on the looking of the angles of the antenna only, we are going to be saying as azimuth angle and elevation angle. Okay, so what is an elevation angle means it is an vertical angle formed between the direction of a travel of an electromagnetic wave which is radiated from the earth station antenna. It is a vertical angle forming which is radiated the electromagnetic wave from the earth stations, that is earth station antennas, pointing directly towards a satellite and the horizontal plane. That is going to be calling as elevation angle. That means it is the angle that appears between the line from the earth station to the satellite, and the line between the earth station antenna and the earth's origin is going to be calling as elevation angle. So azimuth angle is the horizontal angular distance from a reference direction, either south or northernmost point of the horizon. So it is mainly defined as an direction where north is equals to 0 degrees. Initially it can be defined in number of ways, but the azimuth angle is defined as a direction where north side is going to be equals to 0 degrees. Okay, that is the azimuth and elevation angle. So in order to understand this, that is an azimuth is nothing but the angle between the local horizontal plane and the plane passing through the earth station satellite and center of the earth is calling as azimuth angle. And to find out the formula for the azimuth angle, that is given as alpha equals to 180 degrees. It is not clear in this formula, just it is looking as an 1800, but it is not 1800, it is 180 degrees plus tan inverse of tan G into tan L into alpha. So that is equals to 180 degrees plus tan inverse of tan G and tan L. Okay, so what it does means, where L is the latitude of earth station antenna and G is the difference between the position of satellite orbit and earth station antenna. Okay, so this is the formula to find out the azimuth angle. So to have a clear cut of the azimuth and elevation angle, you can see this, where the azimuth is the axis of angular rotation. So in this figure you can see this. So you can see this, what is an azimuth angle means, where it is going to be radiating where the signal is radiating this angle, and where the north is going to be having the center of the earth's curvature or the center of the antenna. So this is the difference angle is going to be calling as azimuth angle. Okay, so that means whenever the antenna transmitting some signals towards the atmosphere, this one, the straight line at the same time the north position to the center of the antenna or earth's curvature. Okay, that angle is going to be calling as azimuth angle. We are going to be calling as axis of angular rotation. And when we are having the elevation, you can see this, whenever we are having some ground, this is calling as a base, this is calling as a base. Okay, and this angle you are seeing going to be projecting or it is going to be propagating some signals from the antenna. This angle is going to be calling as elevation. Okay, so you can see this one. From the ground, it is going to be calling as a base of the earth's curvature, and it is having the antenna, it is going to be placed to project or to propagate the signals. This angle, this area is going to be calling, it is forming as an angle, and it is going to be calling as elevation angle. It is clear, I think so. And this is an opposite. Why? Because in this condition we are not seeing with the base of the earth's curvature, we are only having the direction of the propagating of signals, and when the north position of the is going to be center of the earth's base or the antenna, both are going to be same. So this and this line is having some angle, this angle is going to be calling as azimuth angle. Okay, so it is clear. Okay, so this is an azimuth and elevation angle. Okay, it is clear. So when we are having the azimuth and elevation angle, we are going to be calling as the angle that appears between the line from the earth station to the satellite and the line between the earth station antenna and the earth's origin. We are going to be calling as elevation angle, and it is defined as a direction where north is equals to 0 degrees. That is going to be calling as azimuth angle. Okay, this is an definitions of azimuth and this. And whereas elevation angle, it is an vertical angle formed between the direction of travel of an electromagnetic wave radiated from the earth station antenna pointing directly towards a satellite, and the horizontal plane is calling as elevation angle. It is not only calling as, it is the angle that appears between the line from the earth station to satellite and the line between the earth station antenna to the earth's origin is going to be calling as elevation angle. And the next topic is apogee and perigee. So what is an apogee and perigee? So when we are having this figure, it is very clear that when the satellite is in the elliptical orbit, okay, the fastest path, that is longest path from the earth of that orbit is going to be calling as apogee. So you can see this, that means the point that is having the longest path from the satellite to the earth's point, center point, is going to be calling as apogee, and the shortest path is going to be calling as a perigee. Okay, so the apogee is nothing but the point in an elliptical orbit. The satellite is having the fastest farthest path or the longest path from the earth is going to be calling as apogee, and the distance between the center of the earth to the apogee is called apogee distance. And when we are calling as perigee means the point in an orbit, the satellite located closest to the earth is called as perigee, that is shortest distance. Okay, so the distance between the center to the earth to the perigee is going to be calling as perigee distance. Okay, in circular orbit, the apogee and perigee are going to be equal. Why? Because it is in the elliptical position or elliptical orbit, so for that we are having the difference between the apogee and perigee. But in our circular orbit, the apogee and perigee both are is going to be equal conditions. Okay, so that is the difference between the apogee and perigee. Okay, so what is an apogee means? When the satellite is in the elliptical orbit, the farthest point from the earth of that orbit is going to be calling as apogee, and the point in an elliptical orbit, the satellite is farthest from the earth is called apogee, and the distance between the center of the earth to the apogee is going to be calling as apogee distance. Okay, and what is a perigee means? When the satellite is in elliptical orbit, the lowest path or lowest point from the earth of that orbit is going to be calling as perigee, and the point in an orbit, the satellite located closest to the earth is going to be calling as perigee. The distance between the center of the earth and perigee is going to be calling as perigee distance. But we have to know that in a circular orbit, the apogee and perigee are going to be both are equal. Why? Because we are considering with the elliptical orbit, so for that it is a difference between the apogee and perigee. In our circular orbit, it is not having the difference between the apogee and perigee. Both are going to be equal in this apogee and perigee. And the next one is uplink frequency and downlink frequency. So what is an uplink frequency means? It is a communication link frequency from the transmitting earth station to the satellite. That means whenever we are transmitting some signals from the earth station, from the antenna, the signal is having some frequency. That communication link frequency is going to be calling as uplink frequency. So in the C band, the uplink frequency is 6 gigahertz, and in the Ku band, the uplink frequency is 14 gigahertz. So what is an downlink frequency? Means it is an communication link frequency from the satellite to the receiving earth station. We are going to be calling as downlink frequency. So in the C band, the downlink frequency is 4 gigahertz. In Ku band, the downlink frequency is 12 gigahertz. Okay, so based on our bands used in our communications, we are having the different frequency. So basically in our satellite communication, mainly we are going to be using C band and Ku band and Ka band. Okay, it is mainly used in our applications. Okay, so this is the uplink frequency and downlink frequency. We are having some quiz on this topic. So what is that? Means the earth area covered by a satellite radio beam is known as. The options are beam width, second one is bandwidth, the third one is footprint, the last one is zone. So earth area which is covered by a satellite radio beam is going to be known as. So what is an option? So please note this question. So the earth area which is covered by a satellite radio beam is known to be, first option is beam width, second option is bandwidth, the third option is footprint, and fourth option is zone. So what is an answer? That is C, that is footprint. That means footprint is the earth's area covered by a satellite radio beam. Okay, so that can be seen with this, how much area is going to be covered by a satellite. So that means the earth area covered by a satellite radio beam is known to be footprint of the satellite. Okay, this is an answer. Next. So what kind of battery is going to be used by older satellites? So what type of batteries are going to be used in our older type of the satellites? So what is the options? The first one is lithium, the second one is lead, and the third one is hydrogen, and the fourth one is magnesium. So what is an answer? So that means what kind of battery is going to be used by our older satellites, whether it is lithium, whether it is hydrogen, whether it is magnesium, whether it is lead. Okay, so what is the option? So please note this question. So what kind of battery is going to be used by our older satellites? So whether it is lithium, whether it is lead, whether it is hydrogen or magnesium. So what is an answer? That is C, we are going to be calling as hydrogen. That is, the battery is made up of the hydrogen in our older type of the satellites. Okay, and next. To make antenna more directional, either its size must be increased or what should be increased? That means in order to make the antenna more directional, what should be increased or decreased? Okay, the options are, the first option is the number of its feet horns must be increased. The second option is the frequency of its transmission must be increased. The third option is its effective isotropic radiated power, that is EIRP, must be increased. And the last one is its footprint must be increased. That means in order to make the antenna more directional, either it is size must be increased or what it does. So note this question please. So in order to make the antenna more directional, either its size must be increased or what it does. So the correct answer is the frequency of its transmission must be increased. So that is the correct answer. The frequency of its transmission must be increased. That is the answer. That means in order to make the antenna more directional, either its size must be increased or the frequency of its transmission must be increased. Okay, so this is the correct answer to this question. Okay, and next, the number of days when Earth's shadow falls on a geosynchronous satellite is, how many days it will requiring the falling on the geosynchronous satellites. Okay, the first option is 88, the second option is 277, the third option is 5 days, or the last option is 10 days. Okay, the number of days when Earth's shadow falls on a geosynchronous satellite is, so how much days it is taking the falls on the geosynchronous satellites. So please note this question. So the number of days when Earth's shadow falls on a geosynchronous satellite is, the first option is 88, the second option is 277, the third option is 5, and the last option is 10. So what is an answer? That is A, which is requiring the 88 days. That means the number of days is going to be 88 days when Earth's shadow falls on a geosynchronous satellite. Okay, it requiring the 88 days when the Earth's shadow is going to be falling on a geosynchronous satellite. Okay, this is an answer. Okay, next question. A satellite signal transmitted from a satellite transponder to the Earth station is, a satellite signal transmitted from a satellite transponder to Earth station is calling as, first one uplink, and the second option is downlink, the third option is terrestrial, the last option is earthbound. Okay, so when a satellite signal is going to be transmitted from a satellite transponder to Earth station is going to be calling as, okay, whether it is uplink, whether it is downlink, or a terrestrial, or a earthbound. So please note this question. A satellite signal transmitted from a satellite transponder to the Earth station is going to be calling as, the options are uplink, and the second option is downlink, and the third option is terrestrial, and the last option is earthbound. So what is an option? What is an answer for this question? So that is downlink frequency. Okay, the satellite signal transmitted from a satellite transponder to the Earth station is going to be calling as downlink. Why? Because whenever the signal transmitted from the Earth station to the satellite is going to be calling as uplink, and a satellite signal transmitted from a satellite transponder to the Earth station is going to be calling as downlink. Okay, a downlink is the correct answer for this. And the next question is, dash is a loss of power of a satellite downlink signal due to Earth's atmosphere. That means, what is a loss of power of a satellite downlink signal due to Earth's atmosphere? So the options are atmospheric loss, path loss, radiation loss, RFI, radio frequency interference loss. So what are the type of the loss? That means dash is a loss of power of a satellite downlink signal due to Earth's atmosphere. So what are the options? Means it is a atmospheric loss, or a path loss, or a radiation loss, or a RFI loss. Okay, so what is that type? So please note this question, please. So what type of a loss of power of a satellite downlink signal due to the Earth's atmosphere? So whenever it is having some changes in the Earth's atmosphere, what is the loss of power which is occurred in a satellite downlink frequency? Okay, what type of loss is going to be getting? Okay, so for that we are having some options. That is, first one is atmospheric loss, and the second option is path loss, and the third option is radiation loss, and the fourth option is RFI. Okay, the answer is path loss. Why? Because I have already told that when it is going to be downlink signal, it is going to be coming from satellite transponder to the Earth station. So whenever we are having some problems across the Earth's atmosphere, there is a loss in our path. Okay, so there is some disturbances, or there is some interferences in our path. So that is going to be calling as path loss. Okay, that is the second option. And the next question is, dash is considered as the unsolved problem in satellite system. So what is considering as an unsolved problem in our satellite system? The first one is coverage, the second one is cost, and the third one is access, the last one is privacy. So what is an unsolved problem in our satellite systems? So whether it is coverage, whether it is cost, or whether it is access, whether it is privacy. Okay, what is an correct option? So please note this question, please. So dash is considering as an unsolved problem in satellite system. The options are: the first one is coverage, and the second one is cost, the third one is access, and the fourth one is privacy. So what is an correct option? Okay, see the answer. That is D, privacy. Why? Because whenever we are using the satellite, we are not having any network security in our satellite systems. Okay, so we are only concerned with the coverage areas, we are going to be concerned with the cost of the satellite, and we are having some access with the satellite, but we are not having any privacy sectors in our satellites. That means we are not having any blocks we can see in our satellites. It is not having any the privacy systems. Okay, that is the unsolved problem in our satellite system. That means coverage can be done, and the cost is going to be considered, and access also is going to be considered, but the privacy is an unsolved problem in our satellite systems. Okay, the D1 is the correct answer for this question. And the next question: as the height of a satellite orbit gets lower, the speed of the satellite is what it is. As the height of the satellite orbit gets lower, that means decreasing, the speed of the satellite will be, the options are, the first one is it will increases or it will decreases, and third one is remains the same, and the last one is none of the above. That means as the height of the satellite orbit gets the decreasing level, the speed of the satellite should be the increasing level or decreasing level, it will remain same, or none of the above. So what is an option? Please note this question. So as the height of the satellite orbit gets decreasing level, that is gets lower, the speed of the satellite should be the increasing, decreasing, it will remain the same, or none of the above. What is an correct answer? That is A. Why? Because whenever we are having a repeater stations, if we having a repeater at a lower distance, the signal strength is going to be very high, and the qualities of the signal is also going to be very high. So for that reasons, as we height of a satellite, that means the satellite is nothing but a repeater. It will work as a repeater only, repeater ring, and it is having the same function, same as the repeater. Okay, in that we are going to be having transponders to downlink the frequency only. So as we increases the height of the, as the height of the satellite getting some lower, that is a decreasing level, the speed of the satellite is going to be increases, not with the decreases or not with this remains the same, and none of the above. This is the correct answer of the this question. Okay, and next question: a geosynchronous satellite is what it does. So it has the same period of that of the earth, or it has the circular orbit, or it has a rotation in our electron equilateral plane, or has all of the above. That means a geosynchronous satellite, that means geostationary satellite, it is also going to be calling as geostationary satellites. What it does, the option is A option is it has the same period of that the particular earth, or it has a circular orbit, it rotates in the equatorial plane, and all of the above. So what is an answer? So please note this question. That means a geostationary satellite or geosynchronous satellite, it has the same period of that of its Earth, or it has a circular orbit, it is rotating in the equatorial plane, or it has the all of the above. So what is the correct answer? That is D. That means a geostationary satellite or a geosynchronous satellite, it is having the same period of that particular Earth. Why? Because I have already told that a geostationary a geostationary satellite is having the same velocity of that of the Earth. That means whenever the Earth is rotating, is having the 24 hours, and at the same time the geosynchronous satellite is also going to be rotating in a 24 hours of one rotation. Okay, that means it is having the same velocity between the Earth and that satellite. Okay, and it is also having a circular orbit. Why? Because it is rotating in a circular way. Okay, and it is having the rotating in the equatorial plane. So it has all these options. That means it has the same period of that of the Earth. At the same time, it has the circular orbit, it has the rotation in the equatorial plane, and all of the above. That is the answer. So the next question. A transponder is a satellite equipment which, the option A is, it receives the signal from Earth station and amplifies, it changes the frequency of the received signal, or it retransmits the received signal, and it does all of the above mentioned functions. What is an answer? That means a transponder is a satellite equipment which will receive the signal from the Earth station and amplifies, or it will changes the frequency of the received signal, or it will retransmit the received signal. So does all of the above mentioned functions also. So what is an correct answer? That is, it does all of the above mentioned functions. That means it will receive the signal from the Earth station and it will amplifies, and it changes the frequency of the received signals, and it will retransmit the received signal, and it does all of the functions. That means a transponder is nothing but a main function in the satellite equipment. Okay, this is about our quiz. So in this session I have told about the azimuth angle and elevation angle and apogee, perigee, and what are the uplink frequency and what are the downlink frequencies. So in this session I have covered with the elevation and azimuth angle of an satellite communication, and what is an apogee and perigee of a satellite communication, and what is an uplink and downlink frequency of this, and we have a small quiz on the above topics also. So I have covered 4 topics on this satellite communication. Okay, it is very clear. And what is an elevation, what is an azimuth, what is an apogee, and what is a perigee, and what is an uplink and what is a downlink of the satellite communication. Thank you for this session.